No. Where can I get the pen? More option? No. Someone help me. Where's the pen? Uh, you can't hear my voice. What happened, Vera? You should turn on your camera. Okay, try to share the screen first. Share content. Okay, share the screen. Okay, now I got a pen. So, can you see my screen now? Okay. Yes, thank you, Zati. So, we're going to start with this small exercise a bit. Word file, new document. Okay. So let's say, forget about this part first. We're going to, okay. For example, you have here 2 gram or maybe 20 gram of liver, okay, sample. And then you have dissolved this, prepare this liver and you smash it, okay, grind it using 100 ml buffer. Okay, let's just put it as 100 ml phosphate buffer. Okay, and then you did the spin the whole thing, spin the sample. Okay, and then you got 100 ml of crude enzyme. Okay, the question is, okay, we have not done the story. Okay, so from that 100 ml, okay, we perform amino sulfate precipitation. We do this salt precipitation, okay, precipitation, and then after spinning and everything, we got around 30 ml sample. Okay, so after that, from that 30 ml, 5 ml, okay, no, 10 ml, 10 ml was taken. Okay, a 10 ml sample was taken to run IEX, ion exchange chromatography. Okay, a 10 ml sample was taken to run IEX, and then the active fraction, okay, make a total volume around 3 ml. It is 3 ml for the active fraction. Okay, so for that 3 ml, okay, 3 ml, and then that 3 ml, okay, was subjected to maybe gel filtration technique. Jet filtration technique, and then we got 2.5 mil. Okay, so the question is, okay, the question, just one question. How many mil for each step in this codification table? Okay, I'm going to prepare the table here so that you get some idea. It will be insert table, and then yeah, so it will be step here, and then this one will be the volume. Okay, so I'm giving you the first answer for the first step, which is we have crude, and then from the crude we have 100 mil. I put it here the mil. Okay, so and then we have, okay, so what do you think? For here, okay, I'll give you, this one will be salt precipitation, and then this one will be IEX, this one gel filtration or size exclusion chromatography. Okay, gel filtration or size SAC. Okay, so fill in the blank here. We have, yeah, 1, 2, 3. Volume for salt precipitation, volume for IEX, and then volume for size exclusion chromatography, because later you're going to add for the protein, what will be total protein, and then total activity. Right. Okay. Activity, and then all of this we can get it based on the, okay, we can get this based on the volume that we have set, right? So what is the answer for salt precipitation, IEX, and size exclusion chromatography? Okay, anyone? You can just type. Let me see the chat. Where? Okay, so okay, what will be the answer for salt precipitation? Okay, what is, okay, okay, Irfan, okay, good. Jannah, okay. Wani, Daniel, correct. Emelina, okay. So, yeah. So salt precipitation, we got it 30 mil. Okay, from the 100 mil, we got 30 mil. Okay, fine. We got the answer for this. I'm going to change with the blue color. Okay. Is it clear, blue color? This blue. Okay. So what happened to IEF? Okay, what will be the volume from the IEX? No. Okay. 10 is Wrong. So what will be the answer? Not 3 mil? No, still wrong. Okay. Make it, read it carefully. We have from that 30 mil sample of the from the salt precipitation. So you run only 10 mil. Okay. From 30 mil, you run only 10 mil. Okay. So from that 10 mil, you got only 3 mil. Okay. Now you need to think, what if you run 100 mil? Okay, because your sample, not 100 mil, 30 mil. Because your salt precipitation here, you have got 30 mil, not 10 mil. Okay, so it will be, how do we get it? Okay, let me show you my screen now. Maybe stop sharing this. Yeah, this one. Can you see? Can you see me holding this? I cannot see what I use. Yes. Okay, so it will be, okay. I think got the answers right, Fatima. Okay, correct. Yeah, Aguana, correct. Okay, so that means it will be 9 mil. Okay, because you have run only, I'm sharing the screen again. Okay, so because the stop precipitation, you have 30. That means from IEX, you will get 9 mil. Because you need to do, okay, a simple calculation. If it is 3 mil, if it is 10 mil, you will get 3 mil. If it is 30 mil, you will get 9 mil. Okay. So this is going to be 9 mil. Okay. And then now, from here, you will get, okay, from that 3 mil, you will get, you will proceed to size exclusion chromatography. So what will be the volume for size exclusion chromatography? Let's check. Hmm? Okay, yeah. it will be 7.5. Okay, so this one will be 7.5 mil. Okay. Do you get it? Someone else? How do we get this? It is from, okay, let me just type here, 2.5 mil. Okay, make it black first. It is actually from 2.5 mil divide by 3 mil multiply by 9. Okay, 2.5 mil divided by 3 mil multiplied by 9 because we have 9 mil. Okay, same goes to this side. How do we get this 9? It is from, please someone just help me to type here. What is it? Put it in chat room. How do you get 9? How do we get 9 for this one? Just type from the chat room. You have got it right, Irfan, Badrina, Fatima, Fatin, Nurul, Waida, Hanani, Arbana, Kowichin. So, how do we get it? For the IEX, how do we get it? Okay, so it is from 3 mil divided by 10, okay, multiply by 30, okay, okay. Why this one we don't have to multiply? Because we have 100 mil, okay, 100 mil crude. Immediately, all this 100 mil is subjected for salt precipitation, and then we got 30 mil. That's why 100 mil directly to 30 mil. Okay, from this 30 mil, okay, only 10 mil, okay, only 10 mil, only 10 mil was taken, okay, 10 mil out of 30 mil, okay, was taken to run, okay, to run IEX, ion exchange chromatography. Okay, so only 10 mil was taken from here to run for IEX. So from that 10 mil, we get only 3 mil. Okay, so 3 mil is coming from 10 mil. So, but we need to calculate for 30 mil because our purification table, we start with the crude with 100 mil and then salt precipitation 30 mil. Okay, so 100, so 10 mil, we got 3 mil. So the way to calculate and get 9 is 3 mil divided by 10 multiplied by 30. Okay, this 30. Okay, and then the story continues with this from that 3 mil. 3 mil from here, okay, was subjected to size exclusion chromatography. And then from that 3 mil, we get 2.5 mil. Okay, from that 3 mil, okay, this from 3 mil, we get 2.5 mil. Okay, but remember, we have the IEF from 9 mil, the previous step. So that means we need to calculate 2.5 mil, 2.5 mil divided by 3 mil, okay, multiply by 9 because 9 is the result from the IEX. And then the final one we get 7.5.
pen and paper.
Huh? Again, Vera, I can't hear you. What are you saying?
No, sir. No, I'm hearing you.
Okay. If you don't want to ask any question, you need to mute your mic. Otherwise, I can hear whatever you are doing. Okay. So
Okay, okay, okay.
okay. So now you got the answer. In reality, in your hand now, basically you have only 2.5 mil, right, in the final step. But the purification table need to be calculated from based on the 7.5 mil, because you have started with the crude enzyme 100 mil. Okay, if you put it here, the answer for IEX, I'm sharing the screen again. If the answer for IEX here, like 3 mil, this one will be wrong. If the answer for the size exclusion chromatography, you put it 2.5 mil, this is also wrong. Because 3 mil is only for 10 mil sample. 2.5 mil is for the 3 mil sample based on the previous one. Okay, so at least if the volume for each step is correct, that means whatever step, I mean the fold of purification, the specific activity, I mean the fold of purification and the yield will be correct, because this total protein and total activity will be calculated based on this area. Right? Okay. So any question for this side? Because we're done with this. You can just type if you have something. You can always go back to this side before we end our class. Okay, you have it here. You can type at any time. So
Doktor,
yes, yes. Question from who?
Doktor,
Who's
why we
talking
need
now?
to multiply by 9?
Why we need to multiply by 9? Okay, it is because the volume from the previous step we get should be 9. Okay, the volume that we get from the previous step is 9. I mean, this is 9. We need to imagine the size exclusion chromatography we run for 9 mil. Okay, because we run everything from the previous one. Okay, because we have got 3. In hand, we have only 3. Even though we have 3, we got 2.5 mil. But we need to remember that previous step from IEX, we will get 9 mil. That's why we need to multiply by 9 here, so that we get the size exclusion chromatography result for 9 mil. Okay, is it okay? Okay, for this one, from 3 mil here, we run all 3 mil. But if we got 3 mil from the 10 mil, out of 3 mil, we run only 2.5 mil, we can. And then the result here, maybe around, we can put it 1.7 mil, we can. Okay, if the result here 1.7 mil based on the 2.5 mil, then here we need to put, it will be 1.7 mil, 1.7, okay, divide by 2.5, multiply by 9 mil. We can, because from the previous step, we will get here 9 mil, because we have from 10 mil 10 mil, we get 3 mil. But if we have 30 mil, we will get 9 mil. Okay. So from this 3 mil, instead of 3 mil, we run 2.5 mil. Still okay. There's nothing wrong with this. So if we run 2.5 mil, and then we get 1.7 mil. So we put it here, 1.7 divided by 2.5 multiplied by 9, because this is 9 from previous step. It is not necessary we need to run 3 mil or run everything from the previous step. Okay, because we are in the phase of optimization, the purification strategy. We don't want to run everything yet, because we just want to know which soap or which condition is the best for the purification, so that we will get the fold and yield to the level that we want. Okay, because by the end of the day, we want to calculate for the fold and the yield. Yeah. From the first step crude, yeah, of course, the yield will be 100%. Okay, after each step, and then this one is going to be one full for the crude. But when we proceed for the last step, for example, size exclusion chromatography step, what is the yield? The yield might be like 50%. Yeah, possible. Yeah, because we have salt precipitation, IEX, and then final one, maybe the result give you like 50% yield. And then with the full, like 8 full, possible. Yeah, but this is optimization step. Okay, this is only 20 gram and 100 ml for sweet buffer. If you have like 1 kilogram, because you know already the optimization, the optimal condition, 1 kilogram of liver sample, and then you dissolve in 5 liter culture. You don't want to purify this from 5 liters. You may just take little bit, but you can calculate the purification table for the 5 liter culture. Okay, any questions? So far, is it clear? We need to move, it's already half an hour, we want to move to the characterization part. Is it okay? Okay, so done. We are going to close this side. Okay, we're going to go for this one, which is the enzyme characterization. I have shared with you in the Putra Blast. You can have a look. Okay, and then okay, so for this part, actually I've done the experiment. I can share with you the video of it. I will try first. Hopefully it works. Okay, so we have here, starting from here. How I'm going to share this. Can I share from how? Okay, we try to log in from my phone later on. There are a couple of videos. Okay, so I'm going to show you what is happening now. Okay, so we have here, we're going to characterize, okay, we're going to characterize the enzyme, okay, which is in this case we are working with sucrase or invertase, okay. Video, okay, I don't have, the video is still from my phone. That's the problem. It is still from my phone. And let me try to send to my PC first. No, it is too big. So let me try. Let me try in Google Drive. Save to Drive. Okay, while waiting for it to be uploaded, we will continue with this. Okay, so now we have here sucrose as the substrate. Okay, sucrose is the table sugar. Okay, it is a disaccharide. Okay, so it is linked by alpha 1 beta 2 glycosidic bond. Okay, so now if we react sucrose, okay, sucrose if we like hydrolyze it by by an enzyme called invertase or sucrase, okay, so you will get molecule of glucose and fructose, okay, because sucrose is made up from glucose and fructose. Okay, why do we need water here? Because it involves hydrolysis. Okay, we have the hydrolysis here where we need the presence of water molecule. Okay, so lipase, sucrase, also, protease, maltase, these are all hydrolysis enzyme. Okay, these enzymes is fall under hydrolysis group where the EC number is the enzyme class number start with 3. Okay, if we have oxidase enzyme, the EC number will start with number 1. Okay, we have 6 class of enzyme, and then invertase start with oxidase, oxidoreductase or something, we start with number 1. So for the hydrolysis, it start with number 3. Okay. So now for this enzyme, which is sucrase, it start with 3 and then the subclass with 2, 1, and 26, the subclass. Okay. So now we are going to check we want to optimize the activity. We want to characterize the properties of invertase. Okay, where this invertase will be used to hydrolyze sucrose, okay, to form glucose and fructose. Okay, I don't know what happened to the video. Maybe I need I don't know, it is still uploading or not. Let me check on the drive. Upload file supposed to be here, right? When we last modified. Let's open. Why it is not here? Okay, I don't think it is in. How do I open it? We try from, if I can send to Discord. Share to general. Okay, you cannot. Okay, never mind. I will try to figure it out later. It cannot be uploaded. I need to combine first. It is too big. The video file is too big. Okay. So now we have the invertase just now, the sucrase just now. We want to characterize. We want to know what is the best temperature or enzyme concentration or the substrate, and then the pH as well as the inhibitor for the invertase. Okay. Yeah. Okay. So now we will go with the first step, and then this is the equipment and reagent required. You can check on this. Okay. So now we have this A. Okay, enzyme experiment. Okay, we want to check the activity of the enzyme versus enzyme concentration. Okay, it will end within 5 minutes. Okay, never mind. I think, yeah, it will terminate at any time. Okay, never mind. We will start this side in the second session. Yeah, I will try to find this while waiting for the second session.